So we didn't talk about the transition metals yet, so we're going to go over those today. And we're going to start with the names, going to the formulas, and then we're going to go formulas to names. Not terribly difficult. The names to formulas is a lot easier because it tells you what the charge is going to be. So notice that manganese can be a +7, +4, or +2 charge if you look at it. So I'm going to go ahead and I'm going to put Mn. But which charge do we use? Well, that's what the point of this Roman numeral here is. So we know that it's going to be a +2 charge. This 2 is referring to that transition metal. That way we don't need to try and figure out what the charge is. And then bromine, which is a -1 charge. And so since that's a +2 and that's a -1, we need 2 of the bromine. And we can just write it as MnBr2. Okay, I will expect like on tests or like if I'm doing an assessment for this that you show me the charges so that way I can tell that you worked it out and that you weren't just Googling the answer. Okay, and then we've got chromium. Chromium is right here, that's Cr. And it's telling us it's a charge +3. Cr +3. And then we've got oxygen, and oxygen is a -2 charge. And here we go, we've got a +3 and a -2 charge. So we're going to have 2 of these will give us a +6, and 3 of these will give us a -6. So we're gonna have Cr2O3 for our final. Okay, now when we go the opposite, we have to figure out what the charge of the transition metal is supposed to be. So it's easiest if we figure out what our negative charge is gonna be. So for bromine, we're gonna have a -1. And if there are 4 of them, that means that our titanium needs to be a +4. And if we look at titanium, we see that +4 is actually the only charge that is documented for that anyway, but you still need to be able to calculate it. So this would be a +4. So then when I write that out, I'm going to call it titanium. And then my Roman numeral 4 to tell me that that's a +4 charge, and bromide. And you're still going to have the IDE ending just like we talked about with the other ones. And our last one for an example is copper. Copper is here, and copper can be either a +2 or a +1. So let's see what we got. We got oxygen is a -2. So that means that since there's 2 of the copper, it needs to be a +1 in order for those to balance out. So then we're just going to name it copper. Parentheses, 1. Oxide. So very similar, it's just a little bit trickier with the transition metals because you have to make sure you have the parentheses when you're naming it, and you have to make sure you have the appropriate charge when you're figuring out the formula. These can also have the polyatomic ions too. So the polyatomic ions doesn't change anything. You're still treating it the same way. The only thing is that if you have the transition metals, you'll have the parentheses or the different charges based upon what they are.